Okay, this is practice 2.1. Number 1, a group of 78 third grade students in Midwestern Elementary School took a self-concept test that measured how well they felt about themselves. Higher scores indicate more positive self-concepts. A histogram and some summary statistics from Minitab for these students' self-concept scores are given below. So here we have data that we are going to use. We're going to have to use the mean that's given to us at 56.85 on one of the problems. We're also going to have to use the standard deviation. Okay, so just want to point out that that is there because when we're doing the z-score, we are going to need that information. Okay, so it says part A, 33 students had self-concept scores that were higher than 62, and one student in the group had a self-concept score of 62, so exactly 62. So we have 33 that are higher than 62, and then we have that one student that is exactly at 62. So we want to calculate and interpret this student's percentile and then also the z-score. So the simple way to do the percentile is just to figure out what percent of students are below a score of 62. So we know that we have a total of 78 students, okay? And we're trying to subtract everything that's higher than 62 from 78 because that's going to tell us what's left over that's below 62. So I'm going to subtract the 33 students that are above a score of 62, but I also need to subtract the student that is exactly at 62. Okay, so 33 plus 1 is 34, and then 78 minus 34 would be 44, and then we want to see what percentage is that out of 78. So we do want to divide the 44 divided by 78, gives us 0.5641. So we would say, rounding that, that's about the 56th percentile, okay? And then from there, we can do the z-score. We don't need that information to do the z-score, but the things I circled above, the mean and the standard deviation, we are going to need those for the z-score. So remember, we talked about the z-score is observed minus mean over standard deviation. Okay, so our observed score is the 62. Our mean score is given in the Minitab printout, so that's the 56.85. The standard deviation is given in the printout, that's the 12.35. Okay, so I'm going to do alpha y equals on my calculator to get the fraction button, and I'm doing 62 minus 56.85 on the top, and then I want to come to the bottom of my fraction and do the 12.35. Okay, so that gives me a z-score of 0.4170. Okay, so it also asks you, it did ask you to calculate, we did that, but it's also asking you to interpret. So put into words what this z-score means, okay? So I'm gonna say a score of 62, that was our observed score, is 0.4170, that's our z-score, standard deviations. Okay, our z-score is how many standard deviations we are away from the mean. And I'm going to go ahead and say that it's above the mean because it's positive. So you want to tell, when you're interpreting the z-score, you want to tell, is it above or is it below the mean? So anytime we get a negative z-score, we're going to say it's below the mean. Anytime we get a positive z-score, we're going to say it's above the mean. Okay, and I am just going to show real quick how we would get the percentile from this z-score. We actually would not do this because if you look at your original distribution, it's not approximately normal. It actually appears to be skewed to the left, and so it really wouldn't be appropriate to be using normal CDF since we don't truly have an approximately normal curve. But just, you know, for practice sake, so you guys will be in the habit of doing this. Once we have a z-score, we go to normal CDF. So to get there, we go second vars, number 2. We want our lower bound, or our lower, I'm just gonna call it lower bound, even though it says lower on our calculator. We want it to be negative infinity, but we don't have an infinity symbol on our calculator unless you use an Inspire, but on the TI-84 we don't. So when we're dealing with z-scores, it's okay to just use -10 to represent negative infinity. The upper score would be our z-score. So we would do 0.4170. And we want to paste it on our home screen and then press enter again to run it. And notice that gives you about the 66th percentile. So if this data were instead on a normal curve, then that would fall, 10 percentile points higher. It would be 66 percentile instead of 56. But like I said, it's not a normal distribution, so it's kind of off a little bit from what we got from just dividing the 44 by 78, the number of students that were below a score of 62, divided by the total number of students. That does give you a little bit of a different percentile. Okay, part B, what is a typical self-concept score for a third grader in this group, and justify your answer. For this problem, we would pick, oh, sorry guys, see if I can put that back aligned up. Scrolling in the wrong spot. We can see from the original distribution that it is skewed to the left. And anytime our data is skewed, we need to use the median to represent the center. So it's skewed, so we're going to use the median. And they do give us the median in the printout. We have it here. There's our median, is 59. So the answer for part B, what is a typical self-concept score? We would say it's the median equal to 59. Okay, and then my justification, what I would say is I'd say since the data is skewed, and you can say left if you want to, so it's skewed to the left, but at least say it's skewed. The median is a better measure of center. Which is our typical, value. So if we would have had an approximately normal or approximately, roughly symmetric distribution, we would be using the mean to represent the typical self-concept score instead. But since it's skewed, we do want to use the median. Okay. Number 2, below is a cumulative relative frequency graph for the lengths and minutes of 200 songs recorded by the Rolling Stones. So if we look at the graph, notice it goes from 0 to 1, but that 1 represents 100%. So when you see the 4, that's 40%. When you're 0.4, that's 40%. The 0.6 is 60%, and so on. So they ask, what are the median and the interquartile range of song lengths? Draw lines on the graph to show how you arrive at your answer. Well, the median would be at the 50th percentile. And so 50th would be halfway between the 0.4 and the 0.6. And it's saying draw a line. So we're going to go from there to there and then see where does that correspond on the horizontal axis for song lengths in minutes. So our median would be at 3.8 minutes. Okay, because it's pretty close to 4. If somebody said 3.9, of course we'd give credit for that. So it's kind of just a ballpark. You want to be on the high side of 3, closer to 4. I'd even take probably the 3.7, but I wouldn't go as high as 4 because it really doesn't match up as far as 4. Okay, and then for our interquartile range, and I would probably abbreviate that to IQR. We want to go 75th percentile minus 25th percentile. So here would be 0.7. So we need to go halfway between the middle 0.7 and the 0.8. So about, okay guys, forgive my alignment here. I'm trying to get there. So that looks like it's about where 0.75 would be. So it's going to correspond, let's see, to about 4.7 is what the answer key gives us. Okay, so it's kind of close to 5. A little bit past 4.5, so they called that 4.7. And again, you're just kind of picking something close. If somebody would have said 4.8, we would give it to them. If they said 4.6, we'll give it to them, as long as it's close. If you call it 5, you went too far and it's wrong, okay? But we would give you something in between there. And so then we need to also do the 25th percentile. In the middle would be 0.3, so we need to go halfway between 0.3 and 0.4. So we want to mark on over, see where that corresponds on the horizontal axis, and the answer key calls that 3.4. I say the way I do it, it looks a little bit higher, but that's okay. Again, we're going to give a range of values that we're going to accept because we're having to eyeball this. So 4.7 minus 3.4 is equal to 1.3, and so that would be an interquartile range of 1.3 minutes. Okay, part B, according to these data, the mean song length was 4.23 minutes and the standard deviation was 1.38 minutes. A music lover who wants to create a mix of songs wants to have 5 seconds of silence between songs. So he needs to add 5 seconds to the length of each song. He also wants to express the time in seconds rather than minutes. Find the mean and the standard deviation of the transformed data. So if we have to convert from minutes to seconds, we're needing to multiply by 60. Okay, so that's the transformation of multiplication. Remember that multiplication, when you're doing transformations, it affects your centers, but it also affects your spreads, okay? But also, they're going to add 5 seconds to each song. And so that's adding, obviously, as a transformation, and that affects the centers, but it does not affect the spread. So to find the new mean, we're going to take the old mean. It says our mean length of songs was 4.23 minutes. We're going to take that 4.23 minutes. We're going to multiply it by 60 because they're wanting us to give the answer in seconds. But we're also going to add the 5, that we're adding those 5 seconds to each song. Okay, so when you do the 4.23 times 60 and you add the 5, you get 258.8 seconds. Okay, when we do our new standard deviation, let's see, we have an old standard deviation of 1.38 minutes. We are going to multiply by the 60 because multiplication does affect spread, but we're not going to add the 5 because when you add a constant to each of your data points, it does not affect the spread. So we're only doing the 1.38 times 60. Okay, so that gives us 82.8 seconds for our new standard deviation. I don't know why my S is not showing up on the top, but that's okay. Okay, part C, last question here. What are the mean and the standard deviation of the Z-scores of song lengths? Justify your answer. So the answer key goes into all this weird stuff. Guys, when you standardize, all I want you to know is that the mean is 0 and the standard deviation is 1. I don't want you to stress about the answer key at all, but if we're doing standardized scores, always mean is 0, standard deviation is 1. So I don't even, on this part, on part C, I don't even want you to show your work. I don't want you to justify your answer. I just want you to say the mean is 0, standard deviation is 1. And if you forget that for some reason, there's a little cheating, legal cheating way. You can go look on your calculator, go second vars, number 2, and automatically defaulted mean is 0, standard deviation is 1. You're going to have to remember the symbols on your calculator if you want to be able to remember which is 0 and which is 1. But the mean kind of looks like an M. It's called mu. It's the Greek letter mu. And then standard deviation is just sigma. Okay, so there's kind of a way you can do it, but that's all I want to see on your quiz is that the mean is 0, standard deviation is 1, and I don't want to see any work shown for that. Okay? And that's it for 2.1 practice.